features many cool functionalities, such as a real-time Markdown editor that every time we type some Markdown content inside it, it will be immediately formatted into the proper Markdown styling. Also, it's gonna have an automatic saving system that will save the content of the notes completely automatically. And finally, we'll also persist all of our notes as files stored in our file system, like any real notes application does it. Before starting, let me give you a quick demo of NoteMark. To create a new note, we can just click on the sidebar top left button, type a name for our note, and create it. On the right side, we have our note editor, where we can insert some Markdown content inside it. You can see as our content is immediately turned into formatted Markdown. We can also scroll through the list of notes that we have already created and select the one we want to view or edit. And finally, we can also remove the currently selected note just by clicking on the top right button. We are going to build this application using Electron, a framework for building desktop applications using HTML, CSS, and JavaScript. We're going to also use React for creating our UI components, TypeScript for having type safety support, Tailwind CSS for styling, Jotai, a simple and powerful React state manager, and finally, a third-party component called MDX Editor to integrate our note editor. So without further ado, let's get started. Okay, the first step will be generating our Electron project, and for doing that, we're gonna open up our terminal and let's type in yarn create at quick start /.
Sell to millions of people online with Shopify's social media and marketplace integration. You can sell your products directly on social channels and reach millions more shoppers by connecting your store to Amazon, eBay, and more. Head over to Shopify and start your free trial today. Sell to millions of people online with Shopify.
GoDaddy has an SSL option to meet your needs, whether you do it yourself or we manage it for you. With GoDaddy SSL certificates, you get the help and support you need to build your online business.
Electron. Basically here we are using a build tool called Electron Bit, which is a modern tool for generating Electron application based on Bit. So here we are prompted to insert our project name, and we're going to insert node-mark, so NoteMark. We are going to use React as a framework, TypeScript support, and we don't want any updater plugin and any mirror proxy. Great, so let's cd inside this new created application and let's install all the dependencies. So while the dependencies are installing, I'm going to explain quickly how this Electron Bit works. So Electron Bit basically it scaffolds an Electron project by using Bit as a bundling tool. So this project are going to inherit some of the benefits of Bit, like odd module replacement, odd reloading, and also support for TypeScript, React, Vue, Svelte, etc. The nice thing is that our Electron project will be already scaffolded nicely, so we don't have to worry about to configure properly the project because this tool will do everything for us. So the dependencies are installed, so we can open up this project on the editor. So let's open up a folder. Let's go under project, YouTube, NoteMark, and let's open it up. It will be already scaffolded nicely. Initial Electron project. You can see there are many because this tool file relating to the code base configuration, such as ESLint configuration or Prettier configuration. We are gonna see soon how to set up those files. We have an Electron builder.yaml, which is a configuration file for when we are gonna have to build up our application for being packaged as a desktop application. We have a specific file for managing the Vite configuration along with an Electron environment. And finally, we have some TypeScript configuration file. And here you can see that we have two separate TypeScript configuration, one for Node environment and one for the web environment, which is related to our browser window process. So the main core of this project structure is under the source folder, where we have three main folders: main, preload, and renderer. In order to explain these three folders, I found an image that will gonna help us understand how an Electron project works under the hood. Okay, so an Electron application is basically divided into two main processes: the main process and the renderer process. The main process runs in a Node.js environment and has access to the Node.js API along with the Electron main process modules. This process is useful for running privileged operation, such as, for example, accessing to the file system and perform operation such as reading a file, writing a file, deleting a file, or whatsoever. So it basically is like a context isolated process to run a restricted operation. Then we have our renderer process, which is basically our browser window, and it basically is where our application lives. So this process is divided in two parts. On the right parts, we have our entry point for our application, which is the index.html, which then connects to an index.ts, where we basically run our web framework, in our case, React. And we have also this left part, which is called the preload script. The preload script basically have access to a restricted set of function from the Node.js API, has access to the DOM API. But the most important part is that is able to access a channel called IPC. This channel is used by the preload script to communicate to the main process. And this will be one of the most important part of our application, because we, at some point, we will want to create files, write files, delete files to store our nodes on the file system. But the only way to perform this kind of operation is to communicate our main process to do that. And the only way to communicate to this main process is using this IPC channel. So let's quickly recap. We have the main process that runs a restricted operation, and the renderer process, which is divided by our React application leaf along with the preload script. If we go back to our Electron project, you can see that we have three separate folders, one for each of the roles that we have seen in the previous image. So we have a folder which contains the index.ts of the main process. We have a preload folder which contains all the files related to the preload script. And finally, a renderer folder where our React application basically will live. So you can see that we have another source folder inside, and here we have an initial React project that the application already created for us. And you can see that we have the entry point, which is the index.html, which links to the main.tsx, and this main.tsx basically runs React under the hood.
Create your own website with ease using Hostinger AI Website Builder. Simply describe what you need in the prompt box and let AI generate a unique website for you. From colors and images to fonts and text, you explain it, AI will build it. Keep what you like, discard what you don't. Customize it all with the easy drag and drop editor. Hit go live when you want to launch your new website and get ready to be discovered on Google. Go online with ease with 24/7 live customer support and a 30-day money-back guarantee. Start using Hostinger AI Website Builder today. Hostinger. 3, 2, on.
And so at this point, we can start to try to run this application and see what happens. Let's start by configuring our printer configuration in order to have our files formatted nicely every time we hit save, and in order to having a consistent format throughout all these files. In order to do this, we have to open up the .vs Code folder, open up the setting.json, and here I'm going to paste a basic configuration for printer. Great, so that was it for this file. And if we open up the printer RC, we can see that the Electron Vite build tool has already a pre-configured printer RC configuration. We can just use this configuration and don't worry about it. Same for the printer ignore, we can leave as is. Next step will be adding some ESLint rules. As you can see here also, Electron Vite has an initial configuration, but we can enhance it a bit. So let's go ahead. So we basically add this rules configuration, where we basically turn off some rules to enhance our code experience. So yeah, that was also it for this ESLint configuration. Okay, next step will be configuring our main process. So let's open up main index.ts and let's give it a look to this file. We have already some configuration going on, and it is like the configuration that Electron Vite has applied for us, and actually is actually quite complete. So let's give it a quick look. For example, here we are basically creating our window. We are assigning a width of 900, height of 670. We are already setting an icon for Linux environment. We are hiding the menu bar, and also we are setting the web preferences. Let's give a quick look to the other configuration that has been already added. For example, here we are showing the main window only when it's ready to be shown. Here, for example, we are denying the possibility to create a new window, and this is okay for our application because we don't need any separate window beside the main one. Here we are just loading our index.html file when everything is ready. What we are doing here is saying that when the app is ready, we can start by setting the user model ID. We are creating the window. This code snippet right here is saying that every time that we click on our application, we are gonna run this code. And basically we are saying, hey, if we don't have any windows available, create a new windows. This is especially useful if we have our, application already opened up. So if it's already opened up, this .length will be greater than 0, so we don't have to create a new window. And finally, we have this event that basically quit our application when all the windows are closed, except on macOS. And this is a common behavior for, macOS desktop application. Anyway, this file is already commented, so you can take your time to read these pre-built comments that was added by the tool that we are using for creating this project. So what I'm going to do now is going inside the web preferences and basically enable the sandbox and set it to true, and also enable the context isolation setting also to true. So these two properties are super important because will enhance the security of our application. For example, the context isolation will make the JavaScript context of the renderer process separated from the main process. And we also have the sandbox properties, which will permits us to sandbox our renderer process to make it more secure. Okay, so that's it for now for the main process configuration, and we can move on. Next step will be configure our preload script. So let's open up preload slash index.ts. What we are going to do here is to remove everything and let's add a custom script. So the first thing that we are going to do is to check that we are running in a context isolated environment. So we are going to say if we are not in a context isolated, we are gonna throw a new error, which is going to say context isolation must be enabled in the browser window. Second step will be adding a try catch where we are gonna use the context bridge, where we are going to expose variable called context. For now, we are gonna leave it empty, and later on we are gonna add all the necessary things that we need here. So let's also add a catch statement where we console log any possible error that can occur. And the same way, we need to go inside the index.d.ts, which basically defines some global type configuration in order to have TypeScript support every time we want to call any of the function that will be available inside here. So we don't want to export this Electron API since we don't need it for this project, but actually we are going to rename this to context, and we are gonna have for now just an empty object, but later we are gonna have some properties and function, and they basically this TypeScript configuration, especially this context field, is the same that we are basically exposing in the main word throughout this context bridge. So for now, let's leave it like this, and we can move on to the to the core part of this project, which is the renderer folder. So let's close up this tab and let's concentrate in the renderer folder. Okay, let's go ahead and let's start by taking a look at this index.html file. So this is a basic index.html file, which is the entry point for our render process. And okay, so we can start by removing some things that we don't need, like the title and this comment right here. And also we can change these content security policies and adding a custom one, which I'm going to just copy and paste it here. So what I've done is adding a custom content security policies to make our application work with some of the libraries that we are going to work on soon. Okay, so inside the body, we can see that we are linking to this script, which is the main.tsx, which is just right here. So this main.tsx is basically where we are going to run our React application. Yeah, actually, we can start removing some unnecessary file, like inside the asset folder. We can remove these icons. Okay, inside the index.css, we can clear out the entire content, because here we are going to use Tailwind for managing the style of our application. Inside the components folder, we can remove this version components. We don't need it. And now let's open up the JavaScript. Let's remove let's remove all the content inside. Markdown editor. Yeah, we can just remove also this and also functionalities such as a real-time markdown editor functionalities such as ready for working on our application itself. A real-time markdown editor, a real-time markdown. So let's close this app.tsx tab. What we are going to do is having like multiple folder under the source folder of the renderer project where we are going to store different type of files. For example, what we have to do now is update our TypeScript configuration and in order to add some path aliases. So let's start by editing our test config and preload process. So let's go ahead and under the field, let's add a new one, which will be and finally import from // and something else. We actually meaning that we want to import from this folder right here, which is source render source. So basically we are saying that we want to import from under this path right here. So we have to do the exact same thing for the tsconfig node.json, which is a TypeScript configuration that this time is not used by the render and preload, but is used by the main process. Great. So let's get started. and setting that result of this project. And also in this case, we are saying every time at // we are actually importing from the source main, so from here, and also the path aliases for importing files from the shared folder. So that was it for the TypeScript configuration, and now we can go ahead with the development. Actually, we are missing another subfolder under the main process, which we are gonna call lib. And this lib folder basically will contain a series of functions that we are gonna use as an API to interact with the file system to save, read, and write some files that will represent our nodes that our application will display and interact with. Great. So now that we have all the folders that we need, we have to update the Electron Vite configuration. So this file basically contains a Vite configuration for every process that Electron use under the hood. So a Vite configuration for the main process, another one for the preload script, and finally another one for the render process. So here we have to specify how to resolve the path aliases that we basically defined inside the TypeScript configuration. So let's go ahead and let's define our resolve property, where we are gonna specify the aliases. So here we are gonna specify, for example, for the main process, the lib folder that we have just created, and this will be resolved under the source main lib. So this one right here. So the main process need also to resolve the head shared folder, which will be resolved under the source shared folder. So every time that we specify add shard, this will be resolved under source shard. Great. Okay, so we need to do the exact same thing also for the renderer process, but this time I'm going to paste all the configuration that we need. So as you can see here, we specified the add shared folder, one for the hook, one for the assets, one for the store, and basically they are mapped nicely with all the folder that we define, just like here. Actually, we are missing another configuration, which is called assets include, where we basically want to import all the assets from source render assets and defining all the possible folders and files. This will permit us to import, all the files that we define inside here as an asset and not as a source code. Great. That was it for the Electron Vite configuration. And now we can move on and starting by adding Tailwind CSS to our project. And let's install Tailwind CSS. We need to run yarn and -d Tailwind CSS, post CSS, and auto prefixer. Next, we are going to run npx Tailwind CSS init-b, which will create the tailwind config.js and the post CSS config.js. Great. Now let's open up the Tailwind configuration file. Inside the content property, we have to specify what file Tailwind have to look out where we are going to use Tailwind. So we can just paste this path right here, source render, and all the file that has this extension right here. And you can see that we are basically telling Tailwind to go under the renderer folder and search for Tailwind classes right here, because the renderer folder will be the only place where our application will live, and Tailwind so all the styling will live only here. Great. Next step will be updating the index.css. So inside here, we have to import all the Tailwind directives, so the base directive, components, and utility. for making Tailwind working properly. Then we are going to extend the layer base. Inside here, we need to use the ID selector for selecting the root ID class. We are going to apply hfull. Another configuration will be updating our HTML and body. We are going to apply full width. We are going also to apply select to none. This is for avoiding to select text inside our windows, because desktop application does not have, generally don't have this kind of user experience where we can select text. So we are going to disable it for our application. Then we are going to apply also a transparent background, because we want a nice blurred effect as a background of our application. We are going also to apply font mono and also an anti-aliased text to make the text looks smoother and nicer. Also, we are going also to add text set to the color white. And finally, we are going to apply overflow hidden to hide all the content that will overflow the window content. Great job. So that was it for our index.css configuration. And now I guess that we need to install some other dependencies. So let's clear out the console and let's add, for example, Tailwind merge. Great. We also need to install CLSX. And finally, we are gonna add also React icons. Okay, great. So let's see why I've just implemented this library. And let's move inside the utils folder. Let's define a new file called index.ts. And let's define a function called cn. Let's extract some arguments, which will be of type class value. Need to import this class value from CLSX. Great. Then we want to run Tailwind merge with CLSX of these arguments, basically. So like this. Obviously, we need to import the CLSX, and also we need to import Tailwind merge from Tailwind merge. Great. This function will be useful later on when we have merged some custom class name with default Tailwind class name, and also applying conditional class name as well. Great job. So let's go ahead inside the app.tsx, and inside here, let's define span element, where we're gonna say hello from Electron, and we are going also to apply some class name like a text of for Excel, text blue 500, and also we try to center this text by using flex full items center and justify center. Yeah, let's try to run our desktop application. So let's run yarn dev. And you can see that it's working properly. We have our string, which say hello from Electron, and we can see that Tailwind is working correctly. And also our Windows is rendered correctly. So I think that our step will be adding some window customization. But for doing that, we have to go inside the main /index.ts. Okay, let's go ahead and let's start to adding some custom styling to our window. We want to apply the center set to true to have like our window to be centered when we open up for the first time. We want the title to be a note mark, which is the name of our note-taking application. We want to disable the frame. Vibrance is set to under window. This is needed for applying a background blur effect. And also we are going to apply a visual effect state set to active. We are gonna set the title bar style set to hidden. So this property is for basically hiding the out-of-the-box top bar that every Windows comes out with. And also we want to adjust our traffic light position, and we are gonna set the X value set to 15 and the Y value set to 10. Great. And that was it for our styling. Now, if we try to rerun our application, you can see that we have a nice blurred background. Actually, here is not super visible, so let me just move it in a place that could be more visible, like inside a second desktop. And you can see that the windows had this nice blur effect, which will, for me, it's super cool to have. So we can also see that the top bar has been hidden and the traffic light has been adjusted a bit, but we don't actually have a way to move our window around, but we will see how we can be able to drag our window around. Let's move into the renderer project, and let's start by defining an app layout.tsx component. The first component that we have to define is the sidebar, which will be used for containing all the list of our nodes. The sidebar will be an aside element and will basically have as class name. We are gonna have basically, we're gonna use tailwind merge, where we are gonna apply some default styling. We'll have a fixed width of 250 pixels. We'll have some margin top set to 10 pixels, an height set to 100% viewport height plus 10 pixels. And finally, we'll have an overflow set to auto in order to render a scroll bar when the content inside overflow the parent container. And we also want to apply some custom class name that we are going to receive from the props. So let's define the component props of an aside element. Can extract the class name here. Great. And we can also extract the children in order to be rendered inside this element. And finally, we want also to spread these props here. Great. This is for building a reusable component, and we are going to apply this pattern for every component that we are going to define throughout this project. Great. So this is for our sidebar layout component. The right part of the sidebar that we are going to call content, which will contain basically our note editor. So this basically will be a simple div element, and we are going to do the exact same thing we did before. So we are going to extract the children, we are going to extract the class name and all the props, and we are going to spread all the props here and also apply a class name where we are going to use a tailwind merge to merge the default style, which will have flex set to 1 to take all the available space except the one text from the sidebar. And then we are gonna use overflow set to auto. And also we are gonna merge it with the class name that we take from the props. We have also to define the children. And actually here we have to return this div. Okay, so actually for this content component, we want also to have a ref prop. And so basically have our component defined like this. Let's define also a content display name. So basically here what we did is forwarding the reference of an HTML div element and getting all the props of a div element, and then basically going here and passing the reference. This will be very useful, this reference prop, because we are going to reset the scroll of this content component when we navigate through different nodes. We need also another component called root layout, which will be the container for this sidebar and content component. So the root layout will be basically a main element. We are going to do the exact same pattern we did for the other component. So let me just paste all the props that we need here. Let's spread out the props. Let's define the children inside the main content. And then let's define the class name, which will use also the tailwind merge, where we're gonna merge the default style, which will be a flex with flex row, because the sidebar and content are basically two column layout in a row. So we are gonna use flex row, and we are gonna also take total height of the screen. And obviously we are gonna merge this with the class name that we get from the component props. Great, that should be it for our layout component. What I'm going to do now, exporting everything from the main entry point file. We can go ahead inside the app.tsx. Instead of rendering this, we can just define our root layout with our sidebar. We're gonna set the text string sidebar as the content of the sidebar. And also we are gonna set a class name where we apply some padding. And also we are gonna apply some border. This border will be red color. And this is just temporary, just to understand how these two components will be laid out. And also we are gonna have our content. Actually here we can remove this dot and use the hat symbol, and this should work. Let's go back and let's define a class name with some border and border blue 500. Great, so let's see the result. Great, you can see that we have on the left side our sidebar with these red borders, and on the right side our content component with blue borders. And here by setting like that margin, we have some room to give to these traffic lights. So great. I think that we did a pretty good job so far. So we can go ahead and actually remove this and also this border, because obviously we don't need it for our final application. And what we are going to do is to add some custom tailwind class for the content, where we are going to set the border left, and we are gonna give a background of using the zinc color, particularly the 900 variants, with the opacity set to 50. And also we're gonna set the border left set to a white 50. Sorry, not 50, but 20. You can see that now we have a darker color for our content, while our sidebar has this softer gray and actually more blurred. And we also add this border left to separate, the sidebar from the main content. Great job. Okay, so if we run again our application, we can see that our window cannot be dragged around, even if I'm clicking on the top side of the window. So we need to figure out a way to let the window be draggable when we want to drag it somewhere in our screen. So in order to do this, we're going to implement a new component, which we are gonna call draggable top bar.tsx. This will be basically another component. We are gonna pass some class name. So basically we want this header rendered on the top side of our application. So if I run again our Electron hub, we want the header be rendered like here. So in order to do this, we're going to position this component absolutely and set the inset to 0. Inset 0 means that we set the property top, left, right, and bottom to 0. We're gonna give this header an height of 8, which should be 32 pixels. And we are gonna give a transparent background. And we actually can use an autoclose tag here. And great, so this is our header, like our draggable top bar. And now we need to import this top bar inside our hub. First off, I'm going to rename this to become a constant variable. I'm going to use this syntax right here to be more compliant to the other components that we are defining. And here we're gonna use a fragment and move all this content inside because we want the draggable top bar be rendered outside the root layout. So here, declare our draggable top bar. Actually here, we want this to be extracted from the components. We have to go inside our index.ts and extracting a draggable top bar here. So now we can remove this, go here, and let's extract the draggable top bar. Okay, actually, if we go back to our draggable top bar, I want to outline where this top bar would be rendered. So we're gonna set a border 4 with some border with red color. And now if we switch to our application, you can see that the draggable is just right here, but it's still not draggable. In order to make it draggable, we need to open up the index.css and adding some new custom CSS here. Specifically, what we are going to do is to select our header with the tag selector. And I'm going to define the WebKit app region to drag. And this will allow our header component to be dragged around. We have to define set the WebKit app region to no drag. This is super important, otherwise our button will not be clickable. This is the proper way to allow our window to be dragged correctly. So if we switch back to our application, now if I hold click on this draggable header, you can see that I can move my window around. While if I click inside other part of the window, obviously the windows cannot be dragged around, but only if I click over here. Great, so we have our draggable top bar. and we can actually remove the border. So now it should look like more clean. It's working as we are expecting the application to work. Great job. Next step will be implementing the two action button for creating a new node and for deleting a node, and we'll place these action button rows over here. So the first component that we are going to define will be placed under a button folder, and inside this button folder I'm going to create a generic action button component. This will be rendered as a button. Next step will be extracting all the props of a button, so like this component props of button. Right, pass these props over here. Great. So next we want to extract the class name and the children, and pass declare the children by the button content. And next define the class name. We are going to use tailwind merge. We're going to define a default style. So our button will look something like this. We'll have a horizontal padding of 2 and vertical padding of 1. We'll have rounded borders. Then we have some border, and the border color will be of zinc 400 with opacity set to 50. Then on over, we are going to apply a background of colored zinc 600 with opacity always set to 50. Then we are going to apply a transition colors and a duration set to 100. And also we are gonna merge with other possible class name we received from the other props. So this will be represented as our a generic action button. So now I'm going to define an index.ts to export our action button from here, and then going inside the root index of our components and export everything inside the button folder. Great job. So let's close some tabs. Okay, at this point, I'm going to create a new node button.tsx. Great. This new node button will use our previously defined action button, and we can actually import this from components. So add /components. Great. As content, we want to display an icon, which I have already selected, and that we are going to extract from React icons. The icon itself is this Lua file signature. So let's define it here. And also let's set the class name. We have a width of 4, age of 4, and the text set to zinc 300. We want also to extract all the necessary props. But actually what we can do here is to inside the action button and define the action button props and reuse this type over here. And at this point, we can do the exact same thing here, because the new node button will is basically an action button. So we can pass all the props over here. The next step will be obviously exporting this new node button. Great. And now let's define the delete node button.tsx. It's basically the same thing we did for our new node button. So let's define an action button over here. Great. Here we can import from components. Great. Next, we are going to extract all the props. So action button props and passing these props, spreading these props over here. And finally, we are going to use this icon, FA rag trash can. So let's set as the content of this component, and let's set some class name with 4, h4, and a text of sync trian. Great, let's export this component over here. Hit node button. And finally, we are going to implement under the component folder a new component called action buttons row.tsx, which will be the container for these two buttons. It will basically be a div containing these two buttons that we have defined. First will be the new node button, and the second will be the delete node button. We can update the import. And here we want also to extract all the props from the div, from a div element, and spread it out here. Great job. Okay, now that we have this action button row, we can import it inside our app.tsx. So inside the sidebar, we are going to remove this sidebar string. We are going to define our action button row, applying this class name. Let's justify between and a margin top of 1. And actually, we have to export this action button row. Great. So here we can just import from add/components. Let's switch back to our application. And there you have it, our action button row with the button for creating a new node and the other button for deleting the selected node. Great job. Okay, great. So our next step will be adding a list of nodes to display inside our sidebar. We're gonna start with some mock data, and later we are gonna to implement a file system based approach to retrieve the nodes directly from the file system. But for now, we'll start with some mock data. Okay, so to implement this, we have to go first inside our shared folder and define a new file called models.ts, which will contain the models of our application. We're going to define two specific types. The first will be a node info, which will basically represent the preview of a node, such as its title and its last edit time. So we want a title, and we want also the last edit time. This last edit time will be a number, since we are going to use milliseconds to represent our date. Second type that we are going to need is node content, will be a string. So this type over here will represent the markdown stored inside a node. Great, that is for our models. Now let's go inside our store and let's define a new folder called mocks. And inside this mocks, let's define an index.ts. And over here, we are going to define some fake nodes that we are gonna use. Let me just paste some nodes I have already created. So we have basically 4 nodes. The first one, which is a title of welcome and a last edit time of basically now, and other 3 nodes. And you can see that we imported the node info model directly from the shared folder. Great job. Okay, now let's close all this tab And let's move on inside the components folder, and let's define a component called note preview list.tsx. So this note preview list will be represented by an unordered list HTML element, and for now we don't want to display anything inside. So now let's import our nodes from /core/mocks, and over here let's extract our nodes mock. Inside our unordered list, let's iterate over these nodes and let's map it over a basic string. Let's return a list item, and as a key we are going to use the title of the nodes. Okay, great. Now let's export this